Hello, we are discussing about GATE 2001 ECE paper, and this question is related to analog circuits. Look at the circuit diagram given. The inverting op amp shown in the figure has an open loop gain of 100. Then find the closed loop gain V0 by Vs. So we know the equation of closed loop gain of inverting op amp. The general expression you can write it as minus R2 by R1, which is nothing but gain of inverting op amp. R2 is nothing but feedback resistor, R1 is nothing but the resistor associated with source Vs. So by that time you can say it as 10 kilo ohms divided by 1 kilo ohm, which is nothing but 10. Minus 10 is going to be the answer. So this answer is going to be wrong. So you cannot do in this way. Why? Okay. So you cannot go in this way. The answer is not minus 10. Remember that one. So you cannot use this equation as minus R2 by R1 for this configuration. When you can use this equation, when you cannot use this equation, that we will see first. Okay. Whenever you are going with op amp, there are two cases. Okay. So you can use that equation, you cannot use that equation. So you can use this equation in case of ideal op amp, if the op amp is ideal. Okay. And second case is nothing but if the op amp is practical but the open loop gain AOL, which is nothing but open loop gain, if it is given in the question, if the open loop gain is infinite, then you can use. Then in these two cases you can use voltage gain of closed loop is equal to minus R2 by R1 can be used. Okay. So for ideal op amp, if it is given that one op amp is ideal, okay, otherwise practical op amp but open loop gain is going to be treated as infinite. In those two cases you can use the closed loop gain equation as minus R2 by R1, but it has given that one open loop gain of 100. So this is practical op amp. It is a practical op amp. So this is practical op amp with finite gain, with finite open loop gain. So at this point, what happens if the open loop gain is infinite? What happens if the open loop gain is not infinite? Okay. So that we will see. Generally open loop gain AOL is going to be defined as output voltage of op amp divided by input difference voltage VID. Okay. So if AOL is going to be infinite, what happens? We'll see. If AOL is equal to infinite, so by that time VID can be defined as V0 by AOL. That is nothing but V0 by infinite. Something by infinite is nothing but 0. So input difference voltage is going to be 0. Input difference voltage is nothing but voltage difference between non-inverting terminal minus voltage difference at inverting terminal. That is voltage difference at non-inverting terminal, voltage difference at inverting terminal will be 0. So that implies nothing but V plus is equal to V minus. So voltage at non-inverting and inverting terminals are going to be virtually shorted. This concept is going to be called as virtual short. So virtual short concept is going to be existing in ideal op amp or practical op amp with open loop gain as infinite. So this is very important. This concept is going to be called as virtual short. Even though they both are going to be different, but they will be at same voltage. Inverting and non-inverting voltages, inverting and non-inverting terminal will be at same voltage. That we are calling it as virtual short. If we know the voltage at one input, definitely we can say the other input voltage which is same as the previous one. Okay. Whereas if it is going to be op amp is finite, we cannot say that one this is 0. Okay. So V plus is not equal to V minus. So there is no virtual short concept for a practical op amp with finite gain. Okay, so by that time you can always go in this equation. V naught is equal to open loop gain times of V plus minus V minus. This is a general equation. V naught is equal to AOL times of VID. So AOL times of VID is nothing but V plus minus V minus. This equation you must use whenever open loop gain is given. If the op amp is ideal, you can use directly this equation. Okay, now we'll proceed with this equation for this circuit. Okay, now we will see how to calculate this one. So this is a circuit given, and for this circuit V naught, since it has open loop gain given, V naught is equal to AOL times of voltage at non-inverting terminal minus voltage at inverting terminal, because general equation is nothing but output voltage is open loop gain times of difference between the signals, difference between the inputs, VID. VID is nothing but V plus minus V minus. So for this one, now V plus is nothing but voltage at non-inverting terminal that is connected to ground. So you can write it as AOL is given as 100 times of 0 minus V minus, that is nothing but voltage at inverting terminal. This value can be calculated by using superposition theorem. So calculate V minus using superposition theorem, because the voltage at that node is affected by Vs as well as by V naught. Okay, so that using superposition theorem we will calculate that V minus using superposition theorem. So V minus, so superposition theorem says that one overall response of any circuit is going to be sum of individual responses whenever you are considering one source at a time. If you consider Vs as one source, by that time V naught should be 0. If you consider V naught as one source, by that time Vs should be 0. So by that time you can write it as Vs times of, if you apply Vs only, by that time it is R2 divided by R1 plus R2 is nothing but V minus, plus only V naught is going to be considering, by that time it will be R1 divided by R1 plus R2. So V minus can be written as Vs times of 10 by 11 and V naught times of 1 by 11. This you can write. So substitute this one. So by that time V naught is equal to 100 times of, okay, minus 100 times of, this minus I can take out, and V minus is nothing but Vs times of 100. So 10 Vs by 11 plus V naught by 11. This you can write. So you can take this minus 100 inside, by that time it is minus 1000 Vs divided by 11 plus minus 100 V naught divided by 11. So this minus 100 by V naught, if you take this side, at that time it will become V naught into 1 plus 100 by 11. 100 by 11 is equal to minus 1000 by 11 Vs. So closed loop gain ACL, closed loop gain is nothing but V naught by Vs, which is equal to, you can write over here, 1 plus 100 by 11 is 111 by 11. So this is minus 1000 divided by 11 into 11 divided by 111. Okay, here you will get 111 by 11. So that I am writing it as this side, if you take it side, 11 by 111. So minus 1000 divided by 111, it is approximately equal to minus 9. So closed loop gain of this circuit is going to be minus 9. So the right answer is equal to B. So this is how you must use this one whenever you are going for the practical op amp, that is op amp with finite open loop gain. Thank you.